look at lesson 7.1, angles, arcs, and we might even start a bit on sectors. Very exciting. This should be page 2 in your SpongeBob packet. So some of our objectives today, we're going to define what radians are, we're going to convert between radians and degrees, and then we're going to find some coterminal angles. So the first question I have for you is, what is an angle? And that's such a hard question because it's one of those basic things that is very difficult to define. Most of the time, if I said, what is an angle, you could draw an angle, but what does it actually mean? Well, angles are created by rotating the initial ray to a terminal ray, and the amount of rotation is what the angle is. So here's my initial ray. We're going to start with initial rays along the positive x-axis, and then we're going to rotate theta degrees until our terminal ray. This Greek symbol right there, that's called theta. Okay, and it's like that. A lot of times we use Greek letters to represent angles. Thinking back to geometry, you had definitions for acute angle, right angle, and obtuse angle. And it was in geometry, but you also probably saw it in earlier years as well. Usually you say an acute angle is an angle less than 90 degrees. I'm going to say an acute angle is an angle that measures between 0 and 90 degrees. Okay, so we want to have that 0 there because we don't want to include any negative angles. That's one of the things we'll talk about today. A right angle is an angle that measures exactly 90 degrees. And an obtuse angle is an angle that measures between 90 and 180. So usually in geometry you said more than 90, but we're going to add the barrier of not bigger than 180 or a straight line. So you're used to measuring degrees in geometry, but we're going to measure 2 other ways as well. So we're going to do degrees, and then we're going to do degrees, minutes and seconds, and then we're also going to do radian measure. So those are the 3 big ways of measuring degrees. So in degrees, one full rotation is 360 degrees all the way around. So that's talking about here's 180, and then all the way around is 360 degrees. So a circle would be 360 degrees around. So our first method is called degrees, minutes, seconds, sometimes abbreviated DMS. DMS is a way of splitting 1 degree, and 1 degree is really, really small. So if this is 90, okay, 1 degree is like that. It's really, really itty-bitty, okay? And it's taking that 1 degree and splitting it into 60 minutes. The conversion factor there is really easy to remember because there's 60 minutes in an hour. But imagine trying to split that angle that I just drew, which I estimated it, but so it might even be a little big. But try to split that into 60 pieces. Those are very small pieces. And then each one of those pieces can be split into 60 seconds as well. So again, that one's easy to remember because 1 minute is 60 seconds, and here 1 minute for a degree is 60 seconds of a degree. So our notation here is 1 degree is equal to 60 minutes, and 1 minute is 60 seconds. You can see that notation there with the little dashes. So if I have 16.4 degrees and I want to write that as minutes, DMS, so I'm converting to degrees, minutes, seconds. I have 16 whole degrees. Then I'm going to take this 0.4 and I'm going to be working with that. 0.4 of a degree. I'm going to do some unit conversions. So this is like what you do in science class. I know 1 degree from this statement right here. 1 degree is 60 minutes. See how I put the degrees on the bottom? I did that so that they would cancel. My degrees cancel. And 0.4 times 60 is 24. minutes. So my answer here is 16 degrees and 24 minutes. Then we could also take this one and convert it to fractional degrees. And that's kind of a funny term that they call it fractional degrees because usually they're written as decimals. So it's a little misleading on the name. So I already have 62 degrees, so that part is fine. I'm going to have to take my 15 minutes and convert to degrees, and I have to take my 10 seconds and convert to degrees. So I'm going to do this one first. So 1 minute is 60 seconds. You can see that's this conversion factor right here that's all at the top of my page. And then 60 minutes is 1 degree. So the seconds are going to cancel, minutes are going to cancel, and I get 10 over 3,600. Yikes. I have to do this one as well. 1 degree is 60 minutes, and I get 15/60. So at this point, I'm going to take out my handy dandy calculator, and I'm going to add 16 plus 15 over the 60 plus 10 over 3,600, and it's going to give me that as my decimal. 16.2527. So, oh, it wasn't 16. Hold on, it was 62. My mistake. I was thinking of the last problem. 62.2527. 62.2527 degrees. All right, so now take a moment and try those two problems. So pause the video and try those for example 2. Okay, did you try them? All right, so this one is going to be 92 whole degrees. Oops, I got my symbols wrong. 60 minutes in 1 degree, and that's going to be 18 minutes. 92 degrees, 18 minutes. And then this one, 96 whole degrees, 30 minutes, 1 degree is 60 minutes. My minutes cancel. 30/60, which is a half. So 96.5 degrees, which sounds like a radio station. Now, these written in DMS, degrees, minutes, seconds, you might be wondering when we might split those, because as we saw at the beginning, it's a very small angle, and I'm splitting it into lots of pieces. Where you see this in the real world is when you're looking at a larger radius. So if you do the radius being the radius of the Earth, okay, that's significantly larger than the one I drew on the board. What you are able to do is split this up into actual, feasibly split it into those size pieces. And this degrees, minutes, seconds, that's used for latitude and longitude when the radius is the Earth. So draw the given angle of 135 degrees. So I'm going to start by drawing along my positive x-axis. And then if I wanted 135, so this would be about 90 because it would be straight up. So 135, I want a little bit over this way. And that's going to be 135 degrees. So that we have a visual of what we're doing. As we take a look at these, positive angles are created by rotating counterclockwise from this positive x-axis. So the one I just drew is a positive 135. Negative angles are created by rotating clockwise. So if this is, maybe we'll say that's 120, that means this angle would have to be negative 240. See how it's rotating the other way for that B? It's really beta. Angles alpha and beta are considered coterminal angles because they have the same terminal side or same terminal ray. Okay. So we're going to stop here, and I want you to take a look at the Desmos activity now. You'll hear back from me soon though.